Alright, we brought the head in from the other room there. It is cooled down. This is several days after we welded this up. We finished blending in the top here that same day, and got all of our welding done where we were happy with it. During the last couple of days there, we've been working on a couple other jobs, but we were also thinking about how we're going to hold this in the lathe and spin it and create a new clean surface on here. Well, in doing so, and also in searching on the internet for a couple other things, researching this head itself, I actually came on a couple sites and actually saw a couple videos and a couple guys with forums, and they used the spark plug hole here to go ahead and hold the head to do some work over here. Now I think that's fine. So what I did is I checked out the thread, pitch gauge and dimensions, and I came up with a 14 millimeter 1.25 lead, which is an oddball size if you're going to go try to find a bolt or something. The reason why I was doing that is my lathe doesn't turn metric. Otherwise I would just turn a slug, turn the shoulder, turn a diameter, thread the threads, screw this thing on, and I'd be good to go. But what I'm going to do is I'm going to put a slug in there, and I'm going to do all the shoulder work and the diameter that's going to set into the recess here, and then I'm going to drill and tap, and then I'm going to put a short threaded piece in there. Well, I went searching around today for wheel lug nuts and everything else, any kind of bolt out on the market that would give me that 14 millimeter 1.25 lead. And the 14 millimeter standards that are out there that you can get on the shelf anywhere around and kind of make something out of it were 14 millimeter 1.5 and 2 on the leads. So what I decided to do is, well, hey, it is a spark plug thread. So I went ahead and I came back, and I actually happen to have a couple of these plugs here. Came out of my Porsche, and they screw right in here. So I have a threaded section that I have on several of these spark plugs, and I got one set up in the lathe, and we're going to go over the lathe and we're going to go ahead and knock that tang off of there, and then we're going to set up the parting tool and we're going to part off this threaded section of the spark plug, and I'm going to use that threaded section in my jig. Alright, so now you have it held in the center, screwed on, held on with the spark plug threads that are tapped in, and it's going into a register that registers this diameter and the registering face that the plug washer seats against. That's a 2 precision diameter and face, and theoretically the rest of this should turn with that if concentric setup was done on the heads to start with. We'll prove that when we get in there as well. Now I don't believe that that is just enough to go ahead and handle uninterrupted cut on a weld buildup, let alone all of these holes in here at a 5-inch diameter. That's what this is, basically 5-inch right here. So I got to looking and I go, you know what? I could use these flat spots back here, but they're small. What do I have in there? Well, I have some small screw jacks, and the small screw jacks actually fit right into there. And I was looking at my 3-jaw, and if I grab the 3-jaw, grab the chunk of material there with the chuck jaws removed, I can still swing these 2 points right here. I can grab 3 equal points of rest with the screw jacks. I can create enough pressure to eliminate the vibration, and also create a 3-point zeroing on this face, and then turn it. So that's my plan, and let's go on over to the lathe now, and I'm going to start disassembling the spark plug. So we got that thread, and then we're going to go ahead and grab a piece of material, throw it in there, and we're going to start machining it to screw our head on. Alright, we got the spark plug in the lathe, and it's running real true. True enough to go ahead and part it off back here in the relief, and then just catch it, and then we can deburr it, and we can get it to use as a threaded stud. One of the first things I want to do is knock off the tang on there, just in case I have to catch it or whatever. I don't want that to catch into my hand. So we're going to go ahead and we're just going to see if a pair of cutters here will take that off. and it does, and it's still kind of got a little sharp edge on there. Let's I'll take one of our junk files that I use for cornering and edging. All right, and we're not concerned with that damage to the electrode there. All right, now this washer right here is gonna hinder us in here, and I think these they spin these things on somehow. So let's just see if grabbing this thing and running in reverse takes that off. Looked like that worked. Okay, there is a little relief in here. Now I'm going to be getting in here with my parting tool, and there's still a little bit of threads in here, and I want to see if I can get a little bit more of this. So I'm going to reach in there with a D&MP here. Let's put it in the right direction. Okay, that gives me enough room to go in there. I just didn't want to get in there narrow, and I didn't want to have unequal pressure on either side of my parting tool. Now we want to go ahead and square our parting tool up, because we just rotated our head around. We don't know exactly where we're at here. So what we do is we go ahead and we take this against this flat side over here. Bring this in. Okay, now we're square. Double check our tension on our jaws. Okay, now I don't know. I've never had one apart. I don't know if just parting down in here until I get to the ceramic or whatever is in the center here, whatever clearance or whatever's in there, we're going to find out. I'm going to part down till I think we're through this outside piece here, or all the way through. It doesn't matter if it stays in there. We'll just grind the rest of this off at the end here. All we need is those outside threads right there for our part. Okay, back out here. Okay, we're down to the ceramic. The ceramic is part of the other end there. Will this actually pull off of here? We don't know. Here's another thing we can do. I'm going to go get a punch, and we know that that ceramic is loose that way there. There we go. Could have did it. So that's what the inside looks like. That's tapered all the way down in through there. And let me bring you out just a little bit, just so that we don't miss any of this here. Let me see. I just want to make sure I don't get burnt. Okay. Okay, somewhere this is swedged or whatever, so that floats right in there. Excellent. I got what I needed. Now we're going to go take a sander and just take that off of there, deburr that a little bit, and then we're going to test the threads going each way into our head. Alright, we took it and went in the sander and deburred each side, and we can thread this in from either direction. And this is the direction the plug would normally screw in. Alright, so now we have a good sound section of threads. Now we need to go ahead and create a stub sticking out of there that will be set that we can machine the diameter fit in this bore and a face sticking out, and kind of clearance to give the rest of this support and clearance for the screw jacks to hit the 3 points that we want. And we're probably going to be jacking that one, and that one. Just my guess. Okay, we've been whittling on this, and we were kind of like we were taking and holding it up till we got this area that's got a curve down to a diameter where we know we can go ahead and cut a register now, and we'll be able to set right in there and maintain this clearance of this wherever this happens to be sitting. Looking pretty good. We got about another 400 to go, so we're just going to take a couple quick cuts here, and then we're going to get on down close to the size and measure that on. Okay, we just touch it off and set 0. And we're going to go in about a 1/2 inch here. That looks pretty good. All right, 2 50,000 cuts here, and then that'll make our about a 400. We should have about another 25 after these 2 cuts. Let's hold this piece up here. I just want to look at it a little bit so we can see. All right. I just cranked up the feed about double what it was. That way it doesn't give it a chance to go ahead and give it a terry finish. It'll be a little bit coarser finish, but it's not going to be terry. And it does feel pretty smooth. And it's like 74. And we got to go to like 60. I'm getting 66, so I'm going to sneak up on it. Okay, I'm getting like 67 there, and okay, that likes wants to go on there. So, and it actually is going to be a good fit. I'm going to go ahead and break these corners right here with the my rough file here, and then we're just going to draw a couple strokes on here with a little paper, and I think we'll have a good fit right there. Okay, I like that. I don't feel any rocking, but she does slip right on there. Now we got to go ahead and get the threads in the center of it. And just for curiosity, where do we stand on our screw jacks? Okay, our screw jacks, we have to go around and get our screw jack. Okay, here's the screw jack with it all the way, just the maximum thread contact. So we're gonna be perfect right in that ballpark area right there. And if we get this set up right, we can have the screw jacks have enough material right here on the chuck. That'd be nice. Bring this spot drill in. This is a 3/8 diameter. Our finished hole is going to be the tap size hole for the 14 millimeter 1.25 is a 1/2 inch drill, so which would be 13 millimeter also, so close enough, I should say. What's nice about this is that we don't really have to make it that deep, because the thread is only going to be no more than, you know, maybe a quarter of this. We'll try to grab a little bit more in the aluminum head than we are in the steel mandrel here. So all right, let's change this out to 1/2 inch drill. Alright, I'm going to round up my tap follower, a handle, and the tap, and we'll be right back. Also a chamfer. I want to break this edge right here first. Just kissing it. Okay, we took the chatter out. Well, as you can hear, I got static in the film, and it's because the connection on my microphone is not a good screwed tight ground on a connection to the transmitter. And just like anything else that's new to you, you end up having new problems with it. So I'm going to go ahead and cripple my way through narrating one of my videos, because my normal creating videos is what's on my mind at the moment and what's going through, so I'm actually narrating what's on my mind and the job itself. But I do know that I was talking about this tap that I'm using, which is a 4 flute, and just like other 4 flutes, it's not the strongest tap. And this is actually the very first time I've used this tap, and this is from a set that I got off the Mac tool truck in the late 1980s. 86, 87, somewhere around in there. And it's about the time that I had a Toyota 4Runner, 1984. And when I first came to the Cape, I bought a lot of tools off the Mac tool truck, and this was in that set. So anyhow, I'm making sure I flood it with a lot of Tapmatic, and I bring it in there very gently, and I break the chip once in a while, especially down at the bottom. Before you come back out with a 4 fluter, it is a good idea to go ahead and make sure you back the chip, break the chip, and get it running free so you don't gall on the way back out. And it was pretty painless really to tap this out. Now I get to test fit the spark plug in that we cut off, and I'm just looking at both ends there and deciding which way I wanted it to go in there, which way or which end of that I actually wanted to go into the aluminum head. So now, if I was able to turn metric threads, right now the shape of the item that's in the lathe would be pretty close to what I would turn and thread. And this is the final check here, and that is tightened up. And now, okay, now we want to know, how does it turn? So it's just in my normal low speed there, and it looks pretty good. So let's go ahead and let's jack up the speed here, and let's see what it spins up a little faster. I make sure it's tight. And it looks real true to me. I want to bring you in so that you can see how true it is. And what we're looking at is the face in that register right around the OD of the piston diameter, and then the register of the outside where the weld is. And both of those lines look really good. I'm just pointing them out there in the video itself. Okay, I got to thinking about it, and I'm not really sure if it makes a big difference whether that hole supported underneath or the hole on the other side right at the main area of work of weld. It shouldn't be a support with a screw jack behind it. The other 2 points across from it would be equal adjustment side to side in that realm. So we're going to go ahead and give it a shot, and I go ahead and loosen it up, and then I give it a little bit of a tension so that it's firm, it's locked onto the register in the center. Now I know that, you know, that's where the mandrel is made to make it run, and now I'm starting to add in the screw jacks, which actually fit just perfect in there, and the base registers against the chuck really well. And the head actually just sets right down into that little counter bore for each of the holes there on the head itself. Now usually when you're using screw jacks, you got something either toe clamping it on the outside edge or in the center or forejaw, but this is like holding it with a forejaw all the way around the outside edge. And the center bolt is actually drawn and creating a pressure, so now we're able to use the 3 screw jacks to go ahead and adjust the face for alignment as well. If it is out at all, it'll be able to adjust it and catch it by the register and that face, 2 places, around the inside of the bore and then also around the outside edge where we actually welded. Okay, I get two indicators set up, one on the register and one on the face, and I roll the thing over, and we actually find out that we're running 5 thousandths on the register, and we're running about 4 thousandths out on the face. Now also I get into talking that my indicators are actually straight across from each other, and you can compare the in and out with the up and down, and they actually coincide with each other, and they can show that there is a common denominator in the run out of each. Okay, I grab my wrench and I start tweaking back and forth on the little screw jacks and adjusting the indicators in and out, and I'm working basically the register and the inside machine surface in the compression chamber itself. And I figured it was a good starting spot because there's, you know, go from there, and then I also want to use it to compare to the outside face. Now you're working idiosyncrasies or little blems or warpage and things like that, and so I'm playing with those things. I'm finding out what it actually and how close it actually is, and kind of working all of that in. And between the two dials, which the small test indicator actually reads in 0.5 thousandths increments, so its total sweep at that point right there is about 2.5 thousandths, and the sweep up on the big dial was 1 thousandths or a little bit less. And I move it from the inside combustion chamber to the outside flange at the end, and I'm just about satisfied with it right here to run with it.